Hello, my dear students, and welcome back. Exams are just around the corner, so you know what that means. It's time for another super simple revision explainer. Today, we're tackling a really important chapter, the states of water. So let's start with something we all absolutely love, especially on a hot sunny day, a nice, cold glass of shikanji. Now look at our friends Avi and Thirov here. They're enjoying their drink, but they're also wondering about something. That's a great question, isn't it? I mean, think about it. One is hard and solid. You can hold it in your hand. The other is a liquid that just flows away. So how can they possibly be the same thing? Well, today, we're going to become science detectives and solve this mystery together. Let's do this. Okay, here's our plan for today's mission. Think of these as the case files we need to solve. We're going to go through each one, step by step, until we've cracked the whole chapter. Ready? First up, let's solve that shikanji mystery once and for all, and figure out what these states of water really are. So, just think about it. If you take an ice cube out of the freezer and leave it on the table, what happens? It melts, right? It turns into water. And that's our first big clue. It proves that ice and water are just two different forms, or states, of the exact same thing. Simple, Hannah? Case 1 solved. All right, detectives, on to our next case. You've all seen this. It rains, there are puddles everywhere, and then a little while later, poof, they're gone. Where on earth did the water go? Let's investigate. And you know, it's not just puddles. Think about when your mom puts wet clothes out to dry, or when the floor has just been mopped, or even when you see that sizzle on a hot dosa pan. The water just seems to vanish. Is it magic? No way! It's science! The answer to this mystery has a very cool, almost magical-sounding name, evaporation. This is just the process where liquid water turns into an invisible gas called water vapor. It then just floats away into the air all around us. Look at this picture, it shows it perfectly. If you spill a little water on a steel plate, you know for sure it's not soaking into the metal, right? So where does it go? After a while, it's just, gone. That water has evaporated right into the air.
Now listen up, Bacho. This is a very, very important slide for your exams. They love asking about this. There are 3 things that make evaporation happen faster. More surface area, like spreading clothes out. More heat, like a sunny day. And more wind, like putting a fan on. Remember those 3.
Okay, detective team, let's move on to our third mystery. Why do tiny little drops of water appear on the outside of a cold glass? The glass isn't leaking, so what's going on here? I'm sure you've all seen this a million times. It looks like the glass is sweating, but the water is definitely not coming from inside the glass. So, where is it coming from? Let's uncover the clue. The secret here, my friends, is a process called condensation. And guess what? It's the exact opposite of evaporation. All that invisible water vapor that's already in the air, when it touches the cold surface of the glass, it gets chilly, loses its energy, and turns back into tiny drops of liquid water. Mysteries solved. All right, our investigation is really coming together now. We've seen ice turn into water, water turn into gas, and gas turn back into water. So now, let's connect all the clues and look at the big picture. This table is a super quick way to revise for your exams. It shows the main differences perfectly. See? A solid, like ice, has its own fixed shape. A liquid, like water, takes the shape of whatever container it's in. And a gas, like water vapor, has no fixed shape at all. It just spreads out everywhere. So, these are the 4 big changes you absolutely need to know. Melting and evaporation happen when you add heat. And freezing and condensation happen when you take heat away, or cool things down. See? It's all about heating and cooling. Simple. And now, for the grand finale. Let's use everything we've learned to solve the biggest mystery of them all, the water cycle. How in the world do clouds give us our rain? In this one beautiful picture tells the entire story. The sun's heat makes water from oceans, lakes, and rivers, you guessed it, evaporate. This water vapor rises up, cools down, and condenses to form clouds. And when the water droplets in the clouds get too heavy, they fall back to Earth as rain. And the whole cycle starts all over again. It's nature's amazing recycling system. All right, my champions, get ready. Let's do a quick fire revision round to make sure you're fully prepared for your exams. Tension ne lenaga. You've got this. Okay, here is a tricky one that often comes up in exams. Think about what we just learned about evaporation. A fan doesn't make the air hotter, right? It actually feels cooler. So why do clothes dry faster? So, the crucial point here is the wind. Remember those three things that speed up evaporation? The fan creates wind, and this moving air blows away the water vapor that's hanging around the wet clothes. This makes room for even more water to evaporate, and it happens much, much faster. Another classic question. We all know that water from a matka is so refreshing and cool, but what's the science behind it? Think about those tiny, tiny pores in the clay pot and what we just learned.
Arey vah! It's like a natural electricity-free fridge. A matka has thousands of tiny holes, and a little bit of water seeps out to the surface. This water then evaporates, and as it evaporates, it takes heat away from the pot, which makes the water inside nice and cool. Isn't science amazing?
Fantastic work, my science detectives. You have officially cracked the case of the states of water. You've solved all the mysteries. Keep revising these key ideas, and I promise you are going to do great in your exams. All the best.